Hello, I'm Willie, and today I want to share you about the data analysis in Python. And it is a beginning course, so I will not go through some details. And so, what is the scientific computing? Before analysis, let's talk about scientific computing. Think about you like to multiply two arrays element-wisely. You have a list contains 1, 2, 0, 5, and has another list contains 6, 7, 8, 9, 10. I want to do multiply 1 and 6, and 2 and 7, and 3 and 8. So I need to do these things. We want to zip them together, write a for loop to loop each pair, and multiply them together. But how about we just use the A multiply B directly? It might be it makes more sense, but unfortunately we don't have the built-in function for the list. So in this time the numpy is to the rescue. We import the numpy. We use the array from the numpy, and we just need to initiate a numpy array by a pure Python list. And the magic thing is that now we can multiply them together. And this is a important concept about the scientific computing, because when you do the algorithm thing, when you do the data analysis thing, you don't need to think about the for loop. It's too detailed. Sometimes when you think about the for loop, you have to think about, oh, should I begin from the 0 to n, or 0 to n minus 1, or I have to go through a lot of lists. It just interrupt what you are thinking. So when you do the data analysis things, you just and it's better to prevent from the for loop as possible as you can. So this is numpy. Numpy is the foundation, is a fundamental package for scientific computing with Python. It contains a powerful n-dimensional array. And the one we use is the one-dimensional array. And in fact, the numpy has the n-dimensional array. And it has a lot of built-in functions, such like the sum, or the standard deviation, or the average. It also, and the low level of the numpy package is written in C and C++ and the Fortran code. The reason is because it is much faster than the pure Python. So, but we don't know how to write the C code. We don't know how to write the Fortran. So numpy help us we just need to write the Python code, and numpy will help us to deal with the C and the Fortran code. And of course, yeah, because we are doing the scientific computing, we need some linear algebra, we need Fourier transform, and some random number capabilities, a lot of things. And let's talk about one-dimensional numpy array. And just like you use in pure Python, you can get the first element by assigning the 0. You can get the second and you can get the first and you can get the second and the third element by giving a numpy array a slice, a range. This one is awesome. And this operation compare each of the element in the numpy array to 3, and then the result of each comparison will be gathered in the numpy array. So you got 4, 4, 4, 2, 2, and because only the 4 and the 5 are larger than 3, so we got only 2 true. The magic is that we can put the result back to the numpy array. Then in this moment, you can get only the 4 and the 5. Think about if you write a pure Python code, you need to write a for loop to loop through each element, and also you need to write a if statement to compare whether it is larger than 3. In a numpy way, it is much more easy. And then send us the two-dimensional array. We just want to get the first row and the first column, so we assign the 0 and 0. And this one means that we want to get the first row, but we want to get every column, so we get about the column. So then we get the first row. This means that we want to get the first column, so columns means that we get each row, and the 0 column, so we get 1 and 6. And this one is useful. This is the transpose of the original array. So we can now know NumPy provide a lot of lots of built-in function for scientific computing, and it's really useful. And another important thing is that it is much faster than the pure Python. Think about we have two lists, and each of the lists has 1 million elements, and then we multiply them element-wisely, and it took me about 200 milliseconds. How about the NumPy array? It only take me 1 millisecond, so it is 200 times faster than a pure Python. So if you sometimes if you use the Python the pure Python to write something, and you will be much slow. So you need to think in a you need to think it in a metric way. You need to multiply them like the vector. But what if we want to label the data? This data says that we have the name column, we have the gender column, we have the age column. But it doesn't make sense that we put the column name as the data. So somebody is coming to help again. Who is coming to rescue? The Wes McKinney is coming to rescue. Wes McKinney is the keynote speaker in the morning, and he built an awesome tool, pandas. By pandas provide a data frame. It is the most important data structure in the pandas. And so after insert data into your data frame, you will get this data frame. And what we want to do is assign the column names to it. So we got this data frame. So it now makes more sense. And there are some basic manipulations. So what if you want to get the name column? We just assign the name. We just told the data frame I need the name, so it returns the name columns. How about if I want to get all the boys, all the men? So I want to get all the men. So I just need to compare it to M and put the result back to the data frame. Now you get what you want. Think about if you are write the code in a pure Python, it might be very terrible. And the group by probably is the most, in my opinion, is one of the most important function in pandas. And the group by means that I want to the example here means that I want to see the average age of both the female and the male. So I group by the data by the gender, and what I want to know is the age. And how can I aggregate those data? I use the mean function. It is the average function. So I get this data frame. This is what I want. So by this group by function, it's kind of the SQL function. So if you are familiar with SQL, you will like the pandas. There are hundreds of built-in functions. So let's learn some of them by doing a simple project. Our data set is the US baby names. Their name begin from the 1880 to the 2010. What data do we get? Let's take a glance. we got the year data and the gender data and name data and birth data. The row means that there are 7,000 baby named Mary and born in 1880. Of course, Mary is a female, so we have a lot of data. So it seems like it's a CSV file. So fortunately, pandas know how to deal with the CSV file. We simply read CSV, use the read CSV function provided by the pandas. We pass the file name of the CSV file. Then we get this. Then we get the data frame. The head means that we only print the first 5 rows. So it is now the data frame. So the head is to print the first 5 rows. The tail is to print the last 5 tails. The last 5 rows. So you know that there are some female and some girls and some boys. Then how to begin our data analysis? So how about begin from compute the total births of each year? So we write the table for loop to loop through each row and then add the births together. But if you do this, you might take more than 5 minutes to finish the for loop. But if you do this, use the group by function provided by the pandas, you only need a few seconds. And think about SQL. In SQL, you can use the select sum of the births from data frame group by year. But it is SQL. We like something like the pandas use something like the ORM. It's object-oriented. You just your data frame here and your data frame group by years, and what you want to know is the birth, aggregate birth by the sum, and then you get this data frame. But with this data, we don't know. We just know that the birth number getting larger and larger. How about we also separate the data by the gender? If we separate the data by the year and gender, you will get this data frame. By pandas, you only need to pass the year and the gender as the key of the group for the group by, and assign what you want. You want the birth, and give it a aggregate function sum. Then you can get this data frame. But I think it is not human readable. It's not easy to see. So how about using the pivot table? Pivot table is to use the pivot table, we simply assign the year as the row, we assign the gender as the column, and we assign the birth as the value. And how to aggregate our data, our value, we use the sum, so we get this pivot table. I think by this data frame, by this table, is much more clearly. But because there are too many data, there are more than 100 data, so it's waste of time to view each row. Sometimes we have thousands of data, we have 10,000 of rows, so we need a much more efficient way to have a glance at our data. So how about draw a chart? The chart we use the matplotlib to draw this chart, and fortunately pandas have already integrated matplotlib into the data frame, so we just need to use the method plot, and the fixed sizing is the size of the picture, so forget about that. So via the plot we can draw this chart. So Now we have more knowledge of our data. We know that and in the 1900 the number of the men is less than the female, but now the number of the boys are more than the girls now. And what happened here? Probably the World War II. So let's make a case study to see how other people to analyze this data. In this website, the article says that they talk about the last letter of the baby's name. And in 1906, lots of babies' boys' babies' name are end with E or N or S or Y. And nowadays, most of the boy babies have their name ended with N. So it call the phenomenon. It call it the ending name. It call it the last letter revolution. So how about learning from imitating? We just use YouTube pandas. We get data and do the same chart. And first, because we only focus on the last letter, so we get the last letter of our name. The -1 means the last one. It's just same as the normal. It's just same as the pure Python string. So now we have a new column, the last letter. Now, because the article only mentions old boy, so we want to get old boy. So we assign the gender. We compare the gender to the man and assign the result back to the data frame. So we got this data frame. Now we only have the boys. And the next thing we need to because the article only mentioned the 1906 and the 1956 and the 2006. So we only need these 3 years. And in pandas we use the is-in to do the same thing as the pure Python in statement. So we assign a list to the is-in function. We have 1906, 1956, and 2006. And the output is the data with year equals to 1906, 1956, and 2006. And the next thing is to pivot the table, because we want the row. We want the last letter as our row and the year as our column, so that we can draw the picture easily. So we use the pivot table, and the value is the burst. The aggregation function is the sum. Then it's the time to plot our chart. But it seems a bad idea to plot a chart with the line, because the default chart is the line chart. So we have to assign the kind to the plot function. We use the bar chart instead. Now it looks much better. But let's deal the problem. What happened is the blue. There are only few blue in my chart. The reason is that the total burst in 1906 is much less. We can simply sum them together, and we know that, well, the population of the boys is is 10 times more than 1,000 years before. So I think it's better to use the ratio as our data, so we can compare the data easily. So so we need to sum each year. We need to sum each year by the sum function, and then we just need to divide the pivot, divide our data by the sum, by simply divide by a slash. Then you can get this data frame. Note that each column is the sum of each column is 1. So finally, we got this picture. This picture is same with this article mentioned. So now we can analyze the data by ourselves. But you might think that you might be interested about the name ending with N. So if you want to continue research, you can Google it. To do an analysis thing, we always do some easy aggregation, and to do some simple group by some data to get some intuition from data, and then Google, and then get some domain knowledge and back to our data and do more further research. Okay, I still have some time, so I can talk about some more tools for data analysis in Python. The first one, matplotlib. It is the plotting library for Python, and then the pandas have already integrated the matplotlib, so you can plot the chart more easily. The sci-kit is the package for the machine learning. It is very useful. The statsmodels is the Python package for the statistics, and it has a lot of statistics function. You can have the ANOVA, you can have the linear regression there. And the numba is and I think it's the future. Numba convert your Python code, convert your NumPy Python code to the LLVM. So I think it's the future. And the last one is also, I think, is also the future. Breadth is the next generation NumPy array. The breadth is the order of the breadth is the order of the NumPy. So it might be the next generation of the NumPy array. The original NumPy is for the small data and the medium data, and the breadth is the NumPy array for the big data. So I look forward to this project. Okay, thank you.
Is there anyone have questions? Okay, then I have one. 我就用中文讲，就是它都在 pandas 中处理多大的资料？就是
大概几百 mega。
哦，那你有试过就是更大那个资料量的那个处理？
如果你的资料是那个 sparse matrix 的话，你可以就是底层抽掉一些它的 array， 然后换成那个就是 sparse matrix， 然后可以处理到大概是几 G 的 data 吧。大概我碰都是处理在1 G 2 G 上下。
Okay, thanks Willie, and okay, and we have a small gift for Willie, and let's thank him for a great talk.